revision. Okay, recording. So untuk chapter 1, this is your module book. Tapi saya tak boleh kasih version ni kat korang. Version ni version instructor. So, okay. Kita tengok learning outcomes . Let me use my pen. Okay, so after completing this chapter, these are, kejap . So ada tengok beberapa soalan bab 1 kena hafal pasal pi tu ke? Contoh, soalan nak isi padu, lepas tu bagi silinder, tapi unit tu tadi Haikal nak kasih soalan kan, tapi kita ingat Haikal main-main.
Okay, sorry.
Haikal awak cerita soalan awak apa?
Tak, saya tengok soalan bab 1. Kan dia pasal tukar-tukar tu kan, unit kan. So saya dah tengok soalannya macam ni. Dia contoh soalan tu dia silinder. Kan ada formula silinder kan. Contoh dia nak isi padu. Okay, contoh formula dia saya tak ingat lah, mungkin 4/3 pi j kuasa 2 lah contoh kan. Okay, so kita kena hafal ke formula tu? Sebab yelah contoh dia bagi
volume area yang tu adalah standard punya formula. Walaupun kita tak belajar specifically, tapi itu macam standard lah. Macam kita kena tahu apa yang standard lagi pi r squared, benda-benda tu standard volume, area, circumference, apa lagi yang standard yang kena tahu, isi padu kod, benda-benda macam ni lah, benda yang kita dah belajar kat high school area untuk circle pi r squared, untuk ni L dengan L squared, circumference 2 pi r, apa lagi, volume, kalau cylinder H, this is pi r squared times H. Lukislah dulu, dia cylinder ke, dia bulat ke dia punya tapak tu, ataupun petak ke. Kalau petak, L squared times H. It's the normal thing So volume dia kena ada meter cube, area kena ada meter squared, length is meter. Benda-benda yang standard ni kena tahu sendiri And then perlu ke tahu macam miles to feet ke apa ke dalam kalkulator korang? Alamak, tak nampak. Dalam kalkulator korang ada that conversion. So boleh pakai. Tak perlu hafal. Alamak. You just have to know how to use it. How to use the calculator to find that conversion. Untuk yang pelik-pelik lah. Untuk yang tak pelik tu, I'm expecting you guys to remember macam 1000 meter is 1 kilometer. Apa lagi? 60 minutes is 1 hour. Benda-benda yang macam tu memang kena ingat sendirilah. Kalau nak pakai calculator boleh. Tapi better ingat sendiri. Okay, untuk chapter 1, you need to know what is physical quantities and its units, and then you have to know what is base quantities and the units of base quantity. Kena tahu perbezaan base dengan derived quantity. So, derived quantity adalah quantity yang you multiply a lot of base quantities. Contohnya, kita ada length, time, temperature, mass, electric current, amount of substance, luminosity. Semua ni adalah base quantity. Untuk derived quantity, kita akan darab beberapa base quantity. So for example A. For example, this is base times base. This is length times length times length. Semua ni adalah base quantity kan. So bila kita multiply several base quantities, you get your derived quantity. Adakah kena ingat? Kena ingat. So area, volume ni yang tadi kita cakap tadi. So density, benda-benda ni semua standard So what is density? Mass over volume, velocity, length over time, momentum, acceleration, and then force, kilogram per meter second. So force is F equals to ma. If you don't want to remember the unit, you can remember the formula, substitute the SI unit. Meter per second squared or Newton. Kena ingat dua-dua ni. Kenapa dia gerak-gerak? Okay. And then pressure is force over area. Kalau tak nak ingat unit dia, boleh ingat formula. This is Newton over meter squared. Newton per meter squared or Pascal. Okay. I'm just giving you tips on how to remember these things. You can memorize the formula or you can memorize the units. It will give you the same thing lah. You memorize the unit, you convert it into formula. You memorize the formula, convert it into units. Okay. Okay, next, and then scientific notation. So if you have like a very long number, you can convert it into scientific notation. Sometimes they ask you to convert it to scientific notation. Let's say it's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is your number. Ada 9 number. So you want to convert it to scientific notation, and they are asking you convert this to 10 to the power of 9. Contoh. So 10 to the power of 9. So start from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So your decimal place ends up here. So you get 0.79 times 10 to the power of 9. This is how you convert your scientific notation. What if you want to make it into 10 to the power of, let's say, 6 lah. Okay, so same thing, same step. Start from the end. Start from the end. 1, 2, 3, 4, 5, 6. So that is where your decimal point ends. 7, 8, 9 times 10 to the 6. And then what if you want to give me scientific notation that is not 10 to the 9 or 10 to the 6? You just want to give me a scientific notation. So I told you I want your answer to be in 2 decimal places. So kita akan ambil 7.89. So that would be, what is the value at the back? Alamak, what happened? Okay. So what would be the value if it's 7.89? So 1, 2, 3, 4, 5, 6, 7, 8. So this is where your decimal place that I want you guys to give me 2 decimal places, right? So 10 to the 8. So you have this answer, but you want to convert it into 10 to the 12. What should you do? This is your answer. You want to convert your scientific notation yang you have right now. Anggap kita tak pernah buat benda ni. You want to convert it to 10 to the 12. What do you do? So we are missing 10 to the 4 in this guy, right? So 7.89 times 10 to the 8 times 10 to the 4, because I want to make this 12, but I need for this value to stay the same. So I have to multiply with another value that will cancel out 10 to the 4. So I combine these two together. So this becomes 10 to the 12. I multiply this to this guy. So now it becomes 1, 2, 3. Alamak, tak cukup tempat. 1. So ada 3 kosong kat depan. 0.000789 times 10 to the 12. So this is how you convert your scientific notation from one scientific notation to the other lah. So your scientific notation, you have to remember what the prefix is. 10 to the 15 apa? Femto. 10 to the minus 3 apa? Milli. 10 to the 12 tera. You have to remember this list. Kena. Ini dah belajar kan? Waktu high school lagi dah belajar. Okay, so that is how you convert your scientific notation. Let's say you already have this conversion, right? You convert from 7.89 times 10 to the 8. You convert it to 10 to the 12. So 10 to the 12 is tera. So you can write this as 0.000789. Tera, dia punya unit, dia punya symbol is T, capital T. And if we are talking about kilometers, this can become tera kilometer, or maybe selalunya pakai apa? Terahertz. Selalunya terahertz, right? Kita selalu dengar terahertz. So if this guy was in hertz, now it's 0.00789 terahertz. So this is what it means when you hear about terahertz. Okay, next, unit conversion. Let's do this one. Kita recap. Kita dah buat dah sebelum ni. So saya ada soalan ke? Corny-nya korang ni. Okay, so next, convert 100 km per hour to meter per second. Okay, so 100 km per hour, kita nak convert jadi meter per second. So what do? We want to get rid of our kilometer. So kilometer dekat bawah. 1 kilometer is equal to 1000 meter. Okay, so now kita boleh pangkah lah, tapi kita pangkah kemudian. Kita tak nak hour ni, kita nak second. So 1 hour letak kat atas because hour kita kat sini adalah kat bawah. So this is equal to 60 minutes and 1 minute, kita tak nak minute, kita nak second, is equal to 60 seconds. So now comes my favorite part, which is pangkah. Kita tak nak pangkah meter, kita nak pangkah kilometer. Kilometer, hour with hour, minutes with minutes. So now we are left with meter per second. So final answer akan jadi 100 times 1000 over 60 over 60 meter per second. Kalau tahu jalan kerja shortcut macam ni and you are confident that you won't make a mistake, go for it. Okay je, asalkan jawapan betul. Tapi this is how I like to do it because saya ni agak clumsy, so saya prefer step by step. Okay, next. 0.58 cm cube to meter cube. So kat sini ada cube So jangan convert sekali je, kena convert 3 kali sebab dia 3 kali centimeter. So 0.58 cm cube. Okay, kita nak get rid of the centimeter. So 1 meter berapa berapa centimeter? Kenapa saya gagap ni? How many is it? 100, right? 100 centimeter. Tapi kat sini kalau kita pangkah pun akan tinggal centimeter square. So kita kena buat sebanyak 3 kali. 1 meter, 100 centimeter, 1 meter over 100 centimeter. So baru hilang ketiga 3 centimeter ni. So 1, 2, 3. Habis. So now we are left with 0.58 divided by 100, divided by 100, divided by 100. Whatever that value is, jawapan dia akan meter cube. Okay. That is B. C pula. C 1.5 liter to milliliter. Ni prefix. So kita nak convert dia jadi times 10 to the minus 3. Okay. So ada 2 cara nak buat ni. Kita boleh buat cara prefix tadi yang kita buat scientific notation tu. Boleh. Ataupun kita boleh buat macam, anggap dia macam conversion lah. So 1 liter is 1000 milliliter. This is our equation yang kita nak pakai. So, kita buat bawah ni lah. So, 1.5 liter, saya nak get rid of liter. I want to convert it to milliliter. So, 1000 milliliter over 1 liter. Get rid of liter. So, I get 1000, 1, 2, 3. 1500 milliliter. So, this is how I convert something to a prefix. Walaupun sebenarnya macam nak cakap kita anggap dia macam conversion of unit, tapi sebenarnya ni prefix. Boleh juga. So 1 liter is 1000 milliliter. What about if I'm talking about in terms of, selain milli ada apa lagi? What if I'm talking in terms of microliter? Okay, microliter. Microliter adalah sebanyak, tengok sini, 10 to the 6. So 10 to the 6. So this would be our microliter. Macam itulah. Macam mana saya tahu jawapan dia 1 juta ke? Macam mana saya tahu jawapan dia 1 juta? Okay. Kita pakai cara scientific notation tadi. So kita nak value dia kekal 1 liter. So 1 times 10 to the minus 6. Kita nak jadikan dia microliter. So saya kena darab dengan 10 to the 6. This becomes a liter. I know this is micro. 1 times 10 to the 6 microliter. So this is how you get your conversion. Itu boleh letak dalam equation. Okay, so I hope everyone is clear on how to convert to prefix, how to convert to scientific notation, how to convert to units, other units. So kena tahu. Jadi saya let you guys do it yourself. Sepatutnya dah okay dah lah. Okay, next kita go for vector. Deka ada orang guna ke doktor? Deka. Oh yang ni tak ada kot. Tak ada, rasanya tak ada. Selalunya dia go for yang higher numbers ni lah. Senti ke atas. Hektar pun entahlah. Tapi korang ingat kan benda ni. So ingat je semua. Saya pun tak tahu, saya tak ingat apa soalan dia. Okay, so next. Sebab dah lama kita orang buat. Vector Saya ada soalan. Saya ada soalan pula. Saya ada orang tanya saya soalan. So, first of all, untuk geometrical method, kita ada dua types of ways yang kita boleh solve a problem, which is tip to tail and tail to tail. And then for theory ataupun calculation, it's called component method, which is kita resolve jadi x and y tu tambah, axis, all axis tambah, and then all y's tambah, cari magnitude and so on. So where was that? So resolve vectors into components, ax, ay, bx, by, and then tambah semua x's together, tambah semua y's together, and then cari magnitude dengan cara ni. Okay, and then angle. Ini kena tahu yang ni memang confirm kena tahu. Lepas tu, macam mana kita nak jawab soalan ni? Ada orang tanya saya soalan ni. So let's do this one. So a commuter airplane starts from an airport and takes the route shown in figure 1.15. The plane first flies to city A. So kita start pada origin, kita fly to city A, located 150 km away in a direction 30 degrees north of east. Okay. In a direction north of east. Okay, so kena tahu macam mana nak baca ataupun macam mana nak draw this north of east. Draw your imaginary axis. Okay, east. What do you like? So east, west, south, north. So if they say 30 degrees north of east, your off east is your reference point, and then you go 30 degrees towards the north. Contohnya, off east, reference point, we draw it like this. 30 degrees towards north, 30 degrees towards north. Macam ni. Ni patutnya dash. Our reference point here, and then we go 30 degrees towards north. From east. Sebab east adalah reference point kita. Macam kita cakap pasal x-axis, kita cakap 40 degrees with respect to the positive x-axis. In this case, 30 degrees with respect to the east or north of east. Okay, so next it flies for 160 km, 20 degrees west of north. So west of north. Susahnya nak sebut. West of north. So off north ayat dia off north. Maksudnya north adalah reference point kita. Kita start dari sini. Kita go 20 degrees towards the west. So kita akan dapat macam ni. So kalau saya start dari sinilah semua. Kita buat dulu. So 20 degrees over here. This is tail to tail lah. Yang ni dia buat tip to tail. Okay. So next, finally the plane flies 200 km due west. Kalau dia cakap due west ni, teruslah ke west sahaja, tak ada komponen. To city C. So dia pergi ke sini. So 200 due west. Kalau with respect to the east, 180 lah. Tapi dia terus ke west je lah. Anggap to the west je lah. Tak payahlah fikir pasal angle dia. Okay, so find the location C relative to the location of the starting point. So starting point kita semua kat sini kan. Ini adalah tip to tail. This is tail to tail. If you are doing geometrical method, you can use tip to tail. Buat angle betul-betul kat sini A, 30 degrees north of east. And then kat sini buat lagi satu axis imaginary. And then disuruh pergi 20 degrees. Ke sini sama kan? Sama. Cuma kat sini tip to tail. Dia berhubung ataupun dia bersambung. Dia bersambung dekat tip of the previous vector. Kat sini yang orang selalu tersilap. Dia lupa dia kena lukis imaginary axis tu. Dia main bantai je lukis. So tak boleh buat axis untuk setiap vector. This vector has its own axis. This vector has its own axis. This vector has its own axis, but dia senang, dia ke kiri je. Okay, make your axis untuk setiap vector. 20 degrees, sama. Ke sini, sama. This is tip to tail, this is tail to tail. So if you're using this method, your resultant force should be from the initial to the end. This is your resultant. Initial to end. Initial to end. This is from the starting point to the end. Dia akan terbalik daripada perjalanan. Ni perjalanan kita. Dia terbalik dari perjalanan kita. So initial to final. Okay, so this is if you are using your geometrical method and then you will measure using your ruler berapa length dia. Use your scale, convert balik to whatever the length that it should be, and then your angle you should report it with respect to the positive x-axis. Tapi in this case dia bagi negative x-axis. Okay juga. Kalau bagi macam ni boleh. Tapi kita tahu kita punya soalan dalam multiple choice question. Pick the best one that there is. Okay, kalau dia kasih dalam positive x-axis, bagilah dalam positif. Kalau dia bagi in negative, then you find out in terms of negative x-axis. Okay, so how would we do this if we were using component method? Sorry, saya tak habis cerita lagi geometrical method ni. So macam mana kita nak lukis selain daripada angle ni, kita kena fokus angle, setiap vektor ada axis sendiri. So that kita boleh lukis angle dia. Selain dari itu, we need to make sure that our scale is also correct. So let's say I want to make a scale that 10 kilometer is equal to 1 centimeter. So kat sini saya kena lukis accurately using my ruler. Am I recording? Yes. I need to lukis accurately using my ruler that this is 15 centimeter. Of course akan ada error sikit sebab kita punya lukisan tak perfect. But you will get an approximately the same answer. Approximately. So 15 kat sini. And then 160, this would be 16 centimeter to 20 degrees with respect to the y-axis. And then this guy would be 20 centimeter. Let's say your answer over here is 25.7 centimeter. You measure it using your ruler, you get 25.7. Convert it back into kilometer using your scale. Scale ni dipakai untuk semua vektor. Jangan pakai scale lain-lain. Semua kena pakai sama scale. So, 25.7, this is what you measure using your ruler. So the answer is 257 lah, 257 kilometer. This is what you get. Jawapan lari sikit. Tak apa. Asalkan jawapan approximately the same because geometrical method is not accurate. And then your angle, tak kira, ikutlah kalau soalan dia kasih positive x-axis, kira with respect to positive axis. Using your protractor. If they ask you with respect to the negative x-axis, this is the angle that you should be measuring. Okay, so that is geometrical method. What if we are using the component method? Kenapa saya padam ni? Silap. Hilang dah. Kan fikir balik. Okay, tak apa. So no questions saya just recap je laju-laju. Sorry if it's too fast. You can interrupt me anytime. Tak padam pula dah. Tak suka pakai word ni. Okay, let me just redraw it somewhere else. Let's draw it over here. So, kenapa tak boleh padam kan? Let me try again. Boleh lah. Okay. So let's draw our diagram balik. North of east 30 degrees. North of east 30 degrees. And then 20 degrees west of north. This susah saya nak lukis. Buat jarak sikit. So this is 20. Okay, and then this one. Ini atas axis lah. Okay. So first thing first, if we are using the component method, what do? You need to draw direction here. Okay, so this guy, so let's say this is A, this is B, and this is C. This is your AX, this is your AY, this is your BY, this is your BX, nampak kat sini. And then CX, dia hanya, CX adalah C, dia tak ada Y component kan. So apa yang negatif kat sini? Negatif adalah BX. So make sure when you are finding the, when you are calculating for BX, make sure that your answer is negative. So this is your clue over here. So now we do our resolving. AX is equal to A cosine theta. And in this case, A is 150 cosine of 30. Our AX touches the angle over here, so it gets the cosine. So 150 cosine 30. AY is A sine 30. So AY kat sini, dia tak ada angle yang bersentuh dengan dia, so it doesn't get the cosine, it gets the sine. This is sine 30. And then for BX, sama juga. BX kita boleh pakai 20 degrees, boleh. Ataupun kita boleh pakai with respect to the x-axis. Okay, let me redraw this. Sebab dia huru hara kat sini. So let's say this is your B vector kan. B vector kita 20 degrees kat sini. Okay, you can use the 20 degrees or you can use 90 plus 20, which is 110. With respect to the x-axis, you will get the same answer. Okay, so let's do that. So BX is equal to B cosine, I'm using the 120, B cosine 110 or B sine 20. This is how you should write it. You can choose either one, boleh, dua-dua sama. So this guy, the BY component of the vector B touches the angle of 20 degrees. So it gets the sine, it gets the cosine. It's cosine. So therefore your BX gets the sine. In this case, your BX is this way, so this needs a negative sign. Kalau pakai angle with respect to the x-axis, you don't have to worry about the sign. If you are using the angle yang merepek-repek, yang kecil-kecil semua tu, make sure that your positive and negative betul. Okay? And then BY gets the cosine sebab dia touching the 20 degrees. So this is B cosine 20 or B sine 110. Okay, in this case, we know that the BY is positive. Don't have to care about it. Memang akan jawapan dia positif. Yang penting kat sini ialah kita punya BX yang kita kena be careful sebab dia ada negative sign. Okay, next. CX. C cosine, sorry, C is over here. With respect to the positive x-axis, it is 180 degrees. Or you can say it's just 0 degrees. Boleh. Ataupun you can just call it as CX is equal to C. Boleh juga. So if I wanted to use 180 degrees, this will give me the answer. Or minus C cosine 0 or minus CX. Minus C. Sebab C kita adalah CX. So boleh. Semua ni jawapan dia akan sama. And then our CY. Okay, CY. Tak ada. Kosong Tapi kalau korang tak sure, nak juga tulis equation, boleh. C sin 180 or C cosine 0. Sin 0, sorry. Is it sin 0, cosine, cosine? It's sin, sorry. This is sin. Tak suka pakai word. Delete. Bila saya tulis, dia jadi lambat. So sin 180, this is 8 and then sin 0 or just 0 lah. You can just put it as 0 and we accept. Kalau dia minta jalan kira. So this is 0 Alamak, kenapa 0 macam ni? Okay, so then next. Rx is equal to AX plus BX plus CX. Make sure the negative signs are there. Ry, AY plus BY plus CY. At this point, saya harap tak ada siapa yang bela dah pasal ni. Cara resolve and then kumpulkan semua into one equation to get your Rx and get your Ry. So I hope everyone already knows at this point. And then find your magnitude. This one is your magnitude. Don't give me positive, negative here. Tak payah. Just give me the magnitude, the number. the direction is given by your angle. So this one is Rx squared, Ry squared. This is your magnitude. And then theta. Inverse tangent. Put in the value of your Ry. Kalau ada negatif, letak negatif. Kalau tak ada, tak payah. Okay, and then whatever that is. Okay, so there is another issue. What if you get a negative angle in your calculator? What if you get a negative angle in your calculator? Most of the time, your negative angle will tell you that it is below the x-axis, but that is not entirely true. Sometimes it is with respect to the positive x-axis. So for example, saya dah kira soalan ni, saya dapat dalam kalkulator saya dapat minus 61 lah, sama macam ni, tapi saya dapat minus 61.02. If I did not know where my resultant force is supposed to be, I would say, oh, this is 61.02 below the negative, below the x-axis, I would say that. Sebab saya malas nak lukis gambar. But this is incorrect. Sebab kalau kita tengok kat sini, bila kita tambah Rx and Ry, I forgot what the answer is. Saya dah buat dah tadi. Yang ni positif. Sekejap. Ini jawapan dia negatif Rx. But Rx negatif. Let me use a different color. Okay. So I got something that was negative Rx and positive Ry, I think. Ada orang bagi saya jawapan. Sekejap saya tengok check. Oh, minus 124.82. Okay, thank you. Minus 124.82. For X and then 225.35. Okay, thank you. Betul atau lebih kurang? Thank you. Jangan. Kat sini dia susah. Saya tulis tempat lain lah. So Rx dapat jawapan dia minus 124.82. Okay. And then Ry dapat jawapan 225.35. Thank you, Safa. 225.35. Okay. So tengok kat sini, dia punya X is negative, dia punya Y is positive. And you look at your angle punya jawapan, it's a negative. So kalau korang tak lukis beforehand and you say, oh, it's a negative angle, so it must be below the x-axis. It's not correct. You have to draw this guy first. You have to draw it. So macam mana nak lukis? Negative Rx, because Rx is negative. Ry positive. Therefore, your angle of your resultant force ataupun your resultant vector will be in between these guys. Kena kat sini. So, kalau korang cakap negative 61 tu, angle dia macam ni, salah lah kan? Angle dia dekat sini. Walaupun saya cakap boleh extend, tapi kita nak cerita pasal x-axis, right? So, jawapan dia, you guys have to make sure which quarter your vector is in. Make sure which quarter your vector is in. Macam mana nak tentukan quarter mana? Adakah quarter 1, quarter 2, quarter 3 ataupun quarter 4? You draw this guy. Rx positif ke, Rx minus ke, Ry positif ke, Ry minus ke. Draw it first. Your resultant vector will be in between those Rx and Ry. And then whatever angle that you get, you can say, oh, so this is 61.02. It is with respect to the negative x-axis, which makes sense because you got a negative angle. Okay, so if you don't want to answer in terms of negative x-axis, you can jawab in terms of positive x-axis. 180 minus 61.02. 100, so dapat 61.02. Okay, so you get 118.98. Above positive x-axis. Okay, so harap everyone faham Banyak sangat cara untuk buat vektor ni. I hope it doesn't confuse you. Okay, sebab everything at the end of the day, jawapan semua orang patut sama walaupun cara korang pakai berbeza-beza. Okay, it should be the same. Okay, and web science, semua orang punya soalan lain dia punya value, so you can't copy each other. Don't do that, and it's wrong. Don't do that. Don't copy your friends. Okay, so next one. 3 forces. Ini datang dari mana? Okay, so next one. 3 forces A, B, and C are as shown in figure 1.15, where A is 70 units, 40 units, and 25. Sebut laju sikit. Calculate the resultant force and the direction of for A to B and 3C. So how do we do this one? Sama juga, kita resolve dulu. So we have A cosine, we have AX. So AX is A cosine 40, or in this case, so buat teruslah. In this case, it's A is 70 cosine 40, and then you have your AY 70 sine 40, and then your BX adalah 40, it's touching the x-axis, but it's a negative, 40 cosine 30, BY is positive 40 cosine 30, sine, sorry. So sine. Okay, macam tu. Ini 40. Okay, and then CX is bawah ni. So we know that it has a negative CX and a negative CY. So kalau saya nak pakai angle ni boleh. Saya dah tahu dah apa yang saya patut buat. So this will become 25. The x-axis is touching the angle. So this guy should get the sign. Should be negative 10. And then for CY, nak juga kat sini. So negative juga 25 cosine 10. Okay, so this will give you the answer. Tapi tak siap lagi. Dia cakap kat sini 4A plus 2B minus 3C. So what should you do? This is the resultant vector. So kita sama juga. Rx is equal to 4AX. So 4, 70 cosine 40 plus 2B, 2BX minus 40 cosine 30. Faham sendirilah. Dan CX, walaupun tak faham, fahamkan juga. 3CX minus 25 sin 10. Jangan hilangkan negative sign kat sini. Ambil, letak balik kat sini. Okay, so this is your Rx. Whatever value that you get, that is your Rx. And then Ry, sama je. So you would get 4AY, 70 sin 40 plus 2BY, 40 sin 30. Okay, betul next. Minus 3. Ini adalah CY. So minus 25 cosine 10. Okay, so whatever value that you get, sama je. Next, Rx, sorry, R, magnitude, cari angle. Rx squared, Ry squared. Dah jadi lagu dah. Kalau tak ingat juga, rotan diri sendiri. So theta is inverse tangent Ry over Rx. Okay, tangan saya dah penat. Kita tulis benda alih ni. Okay, so saya ada chat kejap. Saya baca. Doktor nak tanya kenapa situ kita guna 10? But angle dia memang 10 kan? Kejap sini, saya tunjuk. Besar kan? Nampak tak? Allah, hilang terus. Hilang terus. Sekejap Let's go back. Sebab tu saya buat dalam PowerPoint tau. Dia word dia lag. Saya tak tahu kenapa. Saya tak ada iPad. Orang lain pakai iPad. Saya tiba-tiba sedih. Kejap, mana soalan tadi? Hello. Okay, sini. Okay, kat sini saya lukis dalam pink colour. Nampak tak ni? 10. Macam tu. Okay, nampak dah Dalam module book ada nanti boleh revise sendiri, buat sendiri. Tengok jawapan sama ke tak. Tak sama tu tengok balik apa yang silap. Okay, next. Saya nak go over Apa lagi? I think our vector punya part kat sini dah okay. Yeah, okay. So I want to show you guys web assignment punya soalan sikit. Before kita masuk chapter 2. Sekarang pukul. Okay, share screen. Okay, yay. Masuk PowerPoint balik. Lega. Okay. So soalan-soalan yang saya dah kumpulkan. Let's see. So yang ni. Okay. So vector A has a magnitude of 8 units. Sama je, kita repeat balik konsep-konsep yang kita dah tengok tadi. So vector A has a magnitude of 8 units and makes an angle 45 degrees with a positive x-axis. Make your axis first. Your imaginary axis. And then vector A is 8 units, 45 degrees. 45 degrees. Okay. And then B also has a magnitude of 8 and is directed along the negative x-axis. Directed along the negative x-axis. Kalau kita nak buat tail to tail method, I'm just going to draw it like this lah. So this is 8 units as well. This is B vector. And this is A vector. So they directed along negative x-axis. Using the graphical method, find the sum vector A plus B. So ni senang je. Kalau pakai graphical method, kita boleh pakai tail to tail ataupun tip to tail. This is tail to tail. So what you need to do is make a line that is parallel to your vectors. Make a line that is parallel and the same length as your vectors. So vector A, dia punya line adalah macam ni. Dan vector B macam ni. So tempat dia bertembung ni, you draw your resultant from the initial point to the tempat bertembung ni. This is your resultant vector. This is tail to tail. So if you want to use tip to tail, same method. So you start with your imaginary axis. Draw your vector. This is vector A. And then vector B, draw your next imaginary axis. Vector B is directed along the negative x-axis. And then your resultant would be, dia kena sama length kan? Saya silap. Length yang agak susah nak lukis ni. Macam tu lah kot. So this is B vector and this is A vector. And then this would be your resultant vector. Your answer should be sama antara dua ni. Walaupun pakai method yang berbeza, jawapan dia akan tetap sama. Okay, so that is A plus B. What if they ask you A minus B? Sama je, but now instead of B vector going this way, we will flip our vector B to be the other directions because it's a negative. So now I change this. Let me copy paste this one. Okay, tak sini And the other one, apa yang akan berlaku kat sini? Nantikan. Kenapa saya ambil? Kejap, copy. Okay, kat sini Okay, apa yang akan berlaku bila kita punya B vector ni negatif So kita buat perbezaan dia. Resultant vector of course akan lain sebab kita punya B vector ada terbalik. Kita buat balik. So B vector akan jadi lain. Resultant pun akan lain. Okay, so B vector saya nak buat dalam pink. So B vector dia cakap directed along the negative x-axis. Kalau negative B, dia akan directed along the positive x-axis. Basically akan terbalik lah. Kalau B macam ni, macam mana negative B? Macam ni lah, terbalik. Allah, saya lah error pula. This is negative B. Dia akan terbalik. Tu saja. Kalau B macam ni, apakah negative B? Macam ni. Terbalikkan saja direction dia. Okay, so in this case, our B sepatutnya ke sini. So now we know that it is over here. So this is our B vector. And in this case, it would be this way. Okay, so now kita draw our resultant. Let's see where our resultant would be. Draw this guy punya line, draw this guy punya line. And the resultant would be in between. And kena capai dekat tempat these vectors bertembung ataupun the dashed line bertembung. And in this case, our resultant would be from here to here and then from the initial to the end. Tengok, direction dia sama. It should be like that. So apa yang patut buat kalau kita ada negative vector, terbalikkan sahaja. It's the same except the direction is flipped. Okay. Next. An airplane flies 200 US in a straight line distance. How far is city C from city A? Yang ni cari distance je, which is the resultant vector pun. Tak apa, kita lukis je. An airplane flies 200 kilometer US. Okay, first draw our imaginary x-axis and y-axis. Apa saya ingat pula ni? Okay. Again. Boleh lah. Korang terima je lah saya punya x-axis ni. Okay, so 200 kilometer US. So this one, 200 kilometer from city A to city B. Let's just call this as vector A. And then 345 kilometer in the direction of 28.5 north of east from city B to city C. North of west. So west is here. Okay, north of west is here. It's going north by 28.5. 28.5. So angle dia akan macam ni. So this is vector A, which was due west, and this is vector B, 28.5 north of west. Macam mana saya tahu direction dia macam ni? Of west ni jadi reference point. Kita pergi sebanyak 28.5 degrees ke arah north. So this is your B vector. Okay. In a straight line distance, how far is city C from city A? So, ini senang je. So, B, X apa, BY apa, AX apa, AY apa. So, I'm expecting you guys to know at this point. RX is AX plus BX. RY is AY plus BY. Sama je. RY, square root This is your magnitude. Nak kena tulis juga ke? Tulislah. Nanti kan orang tak faham. Okay. So this is your steps. So kita plug in our value. So A, 200. It is due west. This is your A. So it's a minus 200. Boleh ke saya nak pakai angle? Boleh. So minus 200 cosine 0. Cosine 0. Or 200 with respect to the x-axis. Cosine 180 will give you the same answer. AY. AY tak ada, kosong. Ataupun nak juga tulis, fine. Or 200 sine 180, boleh. And then BX. BX is 28.5 kat sini kan. So it should have a negative BX, a positive BY. So saya nak jalan kira yang senang, memudahkan hidup saya letak negative sign. So B is 345 cosine 28.5. BY positive 345 sine 28.5. And then dah tambah, cari pakai magnitude punya equation and angle. You should get the answer. Kalau tengok kat sini, dia kira X punya component, which is what we did. And then Y punya component. Okay, one thing to note here. Saya punya komponen untuk X adalah negatif. Tapi kat sini dia positif kan? Anyone knows why? Jawapan dia, skema jawapan dia. Kat sini positif dia punya 200 positif, 345 cosine 28.5 pun positif. Kenapa dia jadikan positif? Tak tahu kan? Okay, saya bagi tahu Sebab dia nak tahu magnitude je. So bila kita ada Rx, walaupun Rx kita negatif punya jawapan, bila kita square root kan dia, negatif tu hilang kan. So dia macam malas nak fikir kot agaknya. Dia buat positif je lah. Tapi in the end kita akan dapat jawapan yang sama. So sebab tu saya tak kasih solution kat korang, sebab solution ni is macam nak cakap, dia akan bagi korang confused lah sebenarnya. So I prefer you guys to follow the steps yang kita buat dalam kelas so that everything makes sense. Kadang korang macam, benda solution bagi macam ni. So saya kena explain pula satu hal. So dah lah saya bagi solution, saya kena explain lagi. Baik saya explain je kan. And then you guys try to solve it yourself. Okay, so faham macam mana nak buat yang ni? Oh gitu, ya betul. So solution tak semestinya akan bagi korang faham. Kadang-kadang dia bagi korang lagi confused. So kita prefer tak bagi solution. Okay, kita prefer bagi explanation. Okay, by kita I mean the teachers lah, your lecturers, all your lecturers. What else? Okay ke soalan ni? So dia asking for the distance D from A to C, which is basically your resultant vector. Sebab you started from A, this is your initial, and your C is your final. Kalau dia tanya from A to C, so daripada, kalau tip to tail this is apa ni? Where is it? So this is A and then B. So your initial to your final is your resultant. Initial to final, A to C. It's asking you the resultant magnitude. And then cari relative to city A. In what direction is city C? Relative to city A, what direction is city C? So basically it's asking you the angle of the resultant vector. Sama je lah. So why is the answer only approximately correct? I already told you this one. I give you a hint. When we do these types of questions, bila kita kira distance yang jauh-jauh ni macam 200 km, 345 km, we are assuming the earth is flat. Tapi jangan jadi flat earther. The earth is round, it's a sphere. So bila kita buat kita punya calculation ni, we are assuming that we are travelling in a straight line. But in reality, our earth is curved. Tapi kita buat macam kita jalan straight line, 345 km. No. So this is just an approximation. So kalau nak betul-betul accurate lah, kena take into account this 345 km ada curve. Kan dah hidup susah tu, kita buat straight line je lah. Okay, so physics suka nak memudahkan hidup kita, kita pakai straight line sahaja, tak payah fikir curve tu. Because we get an answer that is approximately correct. Okay, next. Okay, the league. Yang ni conversion of units. Yang ni unit yang tak wujud Saya rasa lah, saya rasa tak wujud. Alamak. Sekejap Kejap tahu. Okay, next. Sorry. Tadi saya kena jawab bos saya. Okay, so the league. Besarkan sikit. The league variously defined is... Yep.
Nak tanya boleh ke?
Boleh.
Tadi yang pasal, yang tadi Syakir dia tanya 10 degree tu kan? Kan dia punya paksi tu kan dia guna negatif y-axis kan? Kalau buat daripada positive x-axis jadi 260 boleh ke?
Boleh. Boleh. So, pada sama. Sekejap, kita tunjuk balik. Okay, saya bagi semua orang faham apa soalan tadi. Soalan kawan kamu tanya. Kawan korang tanya. Where is it? Chapter 1. Chapter 1. Ini, okay. So, your friend is asking, boleh ke kalau kita nak pakai 10, terlepas dah. Tak nak pakai 10 degrees ni. Kenapa ni? Gendut lah. Okay, dia nak pakai angle with respect to x-axis Boleh. So, kita akan saya nak boycott word. Okay, so ambil angle daripada sini, daripada vector sini kepada positive x-axis. This is 90, this is 90, and what you are left here is 80. So 90, 90, 180, 180 plus 80 is 260 degrees. 260 degrees or 10 degrees, boleh pakai, dua-dua boleh. Make sure positive negative untuk this guy betul. Macam mana nak tahu betul ke tak? Lukis siap-siap. Kalau pakai 260, tak payah fikir dah positif negatif dia macam mana. Memang akan dapat jawapan positif ataupun jawapan negatif. Okay, so boleh. Thank you for that question. Saya lupa nak bagi tahu.
Betul. Berkenaan dengan saya ada tengok slide dalam buku tu ada dot product dengan cross product. Yang tu saya tak berapa nak faham yang tu.
Okay, untuk dot product dengan cross product, you guys have to know how to expand it sahaja. Okay, kita tengok, saya share screen je. Okay, so if they ask you what is the dot product of A with B, vector A with B. So what is the product, what is the answer for A dot B? Is it a scalar or a vector? You should know that. So A dot B akan dapat scalar quantity. Maksudnya kita hanya akan dapat something that is in one axis, and to expand this it will become A magnitude, B magnitude, cosine theta. Cosine theta. What is theta? If you have A vector here and B vector here, just know what is the angle between them. They don't have to be on the X or in the Y axis. They can be all over. Cari angle between them. So if your B vector is this way and your A vector is this way, boleh. What is the theta between them? Put that into your equation. So equation ni A dot B, when you expand it, it becomes A magnitude times B magnitude times cosine theta, which is the angle between the vectors. So this is what you need to know about this dot product and cross product. So cross product pula, cross product, let's use red. So dot, saya tekan red good. Okay. So A cross B. These are two vectors. What do you get what do you get when you cross product two vectors, right? You get a vector quantity. So you need to know the difference between a dot product and a cross product. So if you expand this equation, it becomes A magnitude of A, magnitude of B, sine theta. Sine theta. So theta is the angle between vector A and B. Masih juga. So if vector A is like this, and then vector B is like this, theta is in between them. What about the direction of this? The direction of this vector. Sebab kita dapat vector quantity kan? This is magnitude sahaja. Dia tak bagi tahu kita direction. This equation gives us the magnitude. What about the direction? The direction is 90 degrees with respect to A and with respect to B. Dia akan 90 degrees. So yang ni akan use your right hand rule, but tak payah tahu lagi at this point. You just have to know that the direction of your resultant vector will be perpendicular to both A and both B. This is what you need to know. You need to know how to expand AB cosine theta, AB sin theta. This is what is important at this point. Okay, so okay ke explanation tu? Nanti kita akan apply bila kita belajar chapter lain. Buat masa ni, ini sahaja basic yang perlu tahu. Okay, so next one. The league variously defined is the distance, what time is it? Is the distance a person can travel by foot in an hour. It's still used in parts of route. Okay, whatever. Convert 29.9 meter. 29.9 meter per second to leagues per hour. Kita nak leagues per hour. Assuming that one league is, dia dah kasih kita conversion, one league is 3.48 miles. Saya tak nak tahu pasal miles ni, tapi dia bagi juga. So, So I need to know what is miles in terms of meter. Macam mana nak tahu? I think in your calculator you have it. Let me see. Meter to miles. Ada ke? Macam ada. Meter to miles. Ada miles to kilometer. Boleh lah. Miles to kilometer. But yang ni saya dah Google tadi. Sebab saya malas nak convert pakai calculator. So 1 mile is 1609.344 meter. Okay, fine. We have meter per second. Kita nak jadikan dia leagues per hour. This is our aim. So we start with nak hilangkan meter dulu. So kita hilangkan meter pakai this conversion. So that is 1 mile over 1609.344 ataupun 34 je lah. Boleh. Okay, so that is your 1 mile over is equal to 1609.34 times with we know that 1 league is 3.48 miles. So 1 league 3.48 miles. Kita nak hilangkan miles. Miles kat atas ni nak buang kat bawah lah. So 1 league. What is that? 1 league So now kita dah cover meter, potong meter, mile with mile, we're left with league. Our second is not converted yet. Ini dah senang dah. So kita nak hilangkan second, nak jadikan dia hour. So second, 60 seconds is 1 minute and 60 minutes is 1 hour. Okay. And then potong. Yay. So 60 second dengan second, minute dengan minute. So you are left with league and hour. 2 hour sorry, lupa dia macam tu. So 29.9 divided by this guy, divided by this guy, times with 60, times with 60. Final answer, whatever that is, akan dapat jawapan league per hour. Okay. Banyaklah conversion dia, but it shouldn't be a problem. As long as you know these guys, as long as it's given. Okay, so next, this one. Kalau soalan, just interrupt me, okay? The helicopter view, soalan tu tadi. The helicopter view in the figure below shows 2 people pulling on a stubborn mule. Tak tahu mule tu apa, tapi kita anggap horse je lah. So F1 is 133 and F2 is 84. So dia tanya, find the single force that is equivalent to the forces shown. So if we were to write this in terms of equation, so I'm trying to find a single force that is equivalent. So let's call this force as Fr. And this would be F1 plus F2. So basically we're trying to find the resultant lah. This is the equation for resultant, right? So cari je lah macam biasa. So 100, kita cari Frx. So F1x plus F2x. And then Fry equals to F1y plus F2y. Sekejap saya dah check. Ada soalan ke? Apa benda lah, hidung sumbing lah apa. Hey, okay. So Frx is F1x and F2x, Fry is F1y and F2y. So kita nak cari what is F1x, sama je step kita like always. So F1 cosine, this is F1x. Oops. This is the Fx and this is the Fy, both are positive. What about F2? F2 positive, Fy negative, Fx. So saya lukis siap-siap supaya saya senang kat sini. So this is positive, F1 cosine 60. F1y is F1 sine 60. Dua-dua positif. And then F2x is F2 cosine 75 tapi minus. Sebab dia minus ke kiri kan. Then F2y positif ke atas. Positif F2 cosine, sine 75. Okay. So tambah aje lah. Tengok sini pula. Senang sikit hidup saya. So betul F2x adalah negatif. So this is what they got over here as well. Dia tambah je lah macam biasa, fx squared plus fy squared, you will get 201 Newton and then the angle sama je steps. But sekarang ni dia tanya find the force of a third person would have to exert on the mule to make the net force equal to 0. So tadi we started with this equation. Fr equals to F1 plus F2. And this was our resultant force. So if I wanted to make everything in equilibrium, I should add what? I should add F1 with F2 minus Fr on both sides. What does this give me? This gives me 0. So what did I do? I added resultant force, but in the opposite direction. So F1 plus F2 minus resultant force that I got earlier, so that they cancel out F1 and F2. So now I'm left with 0. So this is related to your experimental setup juga. When you were trying to solve or when you were trying to find the third force to make the system in balance, you were trying to find this guy, Fr. So you had like, oh maafkan saya punya lukisan macam biasalah buruk kan. So this was your F1, F2. You had to find another force to make everything go 0. So this is your Fr, sorry. This Fr, when you add it to the equation, you got a 0. Tapi dalam experimental setup korang anggap dia positif je lah kan, because we're not finding it in terms of resultant force. We're just trying to find a third force that would make everything go 0. So this was the experimental setup. But if you wanted to find the resultant force, then resultant force would be F1, sorry, the resultant force of F1 and F2, it would be minus F3 because you're bringing this guy to the other side, minus F3. Ataupun in this case, we will call it Fr. What is Fr? Fr is minus F3. So what do you get here? What is the resultant force? It is opposite direction to whatever that you put here. That is the resultant force for F1 and F2. But it will not make the system in equilibrium because it's the opposite direction. So if you add F3, you will make the system equilibrium. If you want to find resultant force, you are finding the resultant force lah. You're not making the system equilibrium. You're just finding something that is the summation of F1 and F2. So this is what I was trying to explain to you yesterday. Faham ke? Ada soalan tak pasal ni? So semua orang tengah bela ke? Faham ke? Saya tak tahu. The magnitude for F3 and Fr is the same, right? Yes, it's the same. The direction je terbalik. Direction sahaja yang terbalik. Okay, so again, I'm going to repeat myself. When we want to find a third force that will make this system in equilibrium, the equation will be like this. F1 plus F2 plus F3 equals to 0. But if I wanted you guys to find out what is the resultant force for F1 and F2, so your equation would be F1 plus F2 is equal to minus F3. It's the same force, the same magnitude, but opposite direction. Sebab dia resultant. So kalau kita letak resultant ni dalam equation, dia akan jadi kosong. Okay. So adakah the force sama magnitude? Yes. Adakah direction dia berbeza? Dia akan opposite. So kalau resultant force is this way, then the third force to make system in equilibrium will be the opposite way. If this is 10 Newton, this is 10 Newton as well, just opposite. Okay? So this is what the question is asking you. So jawapan dia sama, 201. To have a zero net force on the mule, the resultant above must be cancelled out by a force that is equal in magnitude and oppositely directed. Okay? So this is recorded. If you guys want to go over this again, you can, okay? Thus, the required force is 201 Newton at 257 from the x-axis. So, kalau kita plot the resultant force ni, kalau kita plot, let's draw our imaginary axis as usual. Saya tak cuba tempat ni. Let's do it somewhere else. Lama lah pula tak masuk chapter 2 lagi ni. Aduh. Sorry. Yep.
Macam ni yang masa doktor kalau kita tambah semua force kita tu mesti jadi kosong ke?
Sebab tu tak bergerak. Kan korang buat eksperimen tu benda tu tak bergerak kan, dia static. So the net force is 0. It's not moving. Betul kan? Tak bergerak kan? Ke Haikal punya bergerak? So this is your resultant. This is your third force to make system equilibrium. So with respect to the positive x-axis, it would be berapa saya pun tak tahu. So yang ni akan jadi 77.2 sama. So 280 minus 77 point. Sekejap. Saya kena buat betul ni. Salah pula. 77.2 from the x-axis. So it's here. Silap. Okay, so 180 plus 77.2, betul ke? 257.2. Okay. From here to here. 257.2. Dia kurang lah. Okay. Okay, kita masuk chapter 2 lah. Saya dah terlambat. Okay. Ada soalan ke? Let me see. Waktu tu dia lupa nama Haikal. Tapi betul ke Haikal yang tanya suka hati saya je? Sebab saya rasa suara sama. Chapter 2. Stop sharing. Semua orang favourite saya kan. Saya tak ada bias pun. Tapi nama Haikal senang ingat. Betul. Tapi tak ada bias kan. Semua orang sama rata sahaja. Ayat cover kan. Tapi betul lah. Saya tak ada bias pun. So jangan rasa macam tu. Okay. Chapter 2. Share screen. Chapter 2. Share. Okay. So kita akan continue with chapter 2. We have like 30 minutes to go. Okay, so apa yang penting untuk chapter 2? You guys need to know what is the difference between displacement and also distance. So if I'm walking over here using through this curved path, that is my distance. But if they ask you displacement, I'm only concerned about the final and the initial. Displacement nak tahu final and initial je, dia tak nak tahu perjalanan pengorbanan korang, dia tak nak tahu. So displacement hanya final and initial. So kalau displacement, ada orang nak tanya soalan ke? So x final minus x initial. Kalau distance kena kira all the curves semua tu lah. So this is the difference between distance and displacement. You have to know the difference. And then the SI unit is meter. What do you guys need to know? Velocity and speed punya equation. Okay, so when we're talking about average velocity, we are talking about the change in displacement over the change in time. When we have the change, it always means final minus initial. So in this case, it's displacement final minus displacement initial over time final minus time initial. For 1D, the average velocity is this. For 2D, the average velocity is tahu ke tak? Tak payah tahu lagi. Ini korang pakai untuk projectile nanti. Okay, so vector quantity sama je lah, ni vector je. So the difference between average and instantaneous is that I told you instantaneous ni is over a short duration ataupun over an instant. So if you are walking from xi to xf, this is displacement. This is your initial displacement and this is your final displacement. You want to know what is your average velocity. You draw a line from the initial to your final and you find out what is the gradient of your line. So this is not a graph. Let me use a graph punya situation. Okay, like this. So if I wanted to know what is the average velocity from point B to point E, contoh, average saya nak average velocity from a displacement time graph. What do? I draw a line from B to E. Walaupun tak kena semua point, tak apa. Asalkan line tu bersambung kat tempat yang saya nak tahu average. So this will be my final and this will be my initial. So equation, kita kena bubuh dalam equation x final minus x initial. What is x? Let's say it's apa ni 20 dengan 20 sini adalah minus 30. So this is 35 lah kot, minus 35 and this is 50 maybe, I don't know. And then over time, the time is 40 and then the time over here is 10, minus 10. So akan dapat jawapan dia minus 85 over 30. Units adalah, this is meter and this is second. So again, when you're trying to find the average, letak line macam ni daripada initial to final. Kalau saya tukar soalan, what is the average velocity from point A to point F? What do you do? Again, draw your line. Find the gradient. Kalau tak nak cari gradient, pakai equation. So gradient kat sini. So 50, apa coordinate kat sini? Maybe it's berapa? Minus 50. 50 and then the coordinates for this guy, sorry, for A is 0 in the X and 30 in the Y. This is 50, sorry. This is 50 in the X and minus 50 in the Y. So now you plug it into your equation tadi, sama. So this is the average velocity from A to F. So let's do that. V from A to F. This was B to E. This is A to F. So now it's, the X is 50. This is the X final. This is the Y final. This is the X initial and this is the Y initial. So 50 minus 0 over minus 50 minus 30. Okay, so this would be your average velocity for from A to F. Dia berbeza sebab dia curve kan. Kalau semua straight line, then your average velocity will be the same at all points lah. So when would that happen? When would the average velocity be equal at all points? For instances like this. So if I ask you what is the average velocity from A to B and what is the average velocity from B to C? Your answer would be the same because the line is basically the same slope. Slope yang sama. So kalau gradient kat sini korang dapat something, gradient kat sini pun korang akan dapat jawapan yang sama. So the average velocity from A to B is equal to the average velocity from B to C. If I ask you what is the average velocity from A to C? Average velocity from A to C is the same as A to B and B to C sebab dia straight line. Tapi saya tak boleh cakap macam tu for this guy because it's a curve. So curve dia special sikit, kena buat satu-satu. Okay, next. So this was a displacement time graph. The displacement time graph, when we find the change of displacement over the change in time, I would get velocity. So from a displacement time graph, I would get velocity. The gradient I get from here is velocity. So if my gradient goes up like that, it's a positive m. If it goes down like this, it's a negative m. Something for you to remember. So yang ni goes down, negative m. Okay, this is how you can check your answer. If I have a velocity time graph, my gradient will be acceleration because I'm finding the change of velocity over the change in time. So acceleration punya equation, velocity over time. Okay, so the gradient that you get from here is m. M is equal to acceleration. Okay, so looking at here is asking you what is the average acceleration from point P to point Q. Sama step macam tadi, you draw your line. Find the gradient or use your equation. Sama je. Find the equation. Who is that? Oh, Aisyah. Saya mute. Okay. So saya ada soalan ke? So siapa yang tanya soalan tadi? Oh Farhan. Sorry Farhan, saya ingatkan Haikal suara macam lebih kurang. Oh kalau Haikal dia akan start dengan so Okay, saya akan ingat. Lepas ni kalau ada orang cakap so tu saya cakap Haikal lah. Farhan punya tagline apa? Nantilah saya kena ingat lah. Tak ingat lah. Banyak pula nak kena ingat kan. Dah lah kena ingat fizik. Kena ingat korang punya tagline pula. Aduh. Okay, so next. Instantaneous acceleration. Farhan macam formal sikit. Okay, noted. Tapi suara diorang lebih kurang saya rasa. Ataupun saya tak dapat bezakan. So an object. Kita nak go for free fall dulu lah nanti kita buat soalan web design. So this one okay ke tak? Okay, linear kinematic equation kena hafal semua. Please remember all these equations. Kena ingat, memang kena ingat. Tak boleh tak ingat. Okay, so kita go for free fall. Free fall, apa yang penting untuk ingat free fall? It's a vertical motion. Vertical motion upward and downward. Projectile yang ada X and Y component. Bila kita cakap pasal free fall, we are expecting everything to happen within one axis. So if I start my free fall down here is going up, this will be a positive U. And going down here will be a negative V. At the maximum height. Lah, kenapa dia tukar tempat pula? At the maximum height. Tengok tu. At the maximum height, your V is equal to 0. Ni kat maximum sini Okay, kat situ. So at the maximum height, your V is equal to 0. Sama macam projectile motion. Okay, for a symmetrical free fall, your U punya value positive on your left side. Contohnya 10 will be the same as your landing velocity ataupun final velocity on your right side. So this would be minus 10. Dia akan sama magnitude tapi terbalik. It's vector, right? Dia akan sama magnitude tapi terbalik. Dekat point paling tinggi, V equals to 0. Time taken to reach the maximum height is T1. And then time taken to reach, to fall down from the maximum height is called T2. And we can see that T1 is equal to T2 if they are symmetrical. Therefore, the total duration is equal to 2T1 or 2T2. Untuk daripada sini ke sini. Okay. Apa lagi kita kena tahu? Okay, acceleration for free fall always minus 9.81 ataupun minus G. Do not forget the negative sign. Kena ada. Linear kinematics kena ada. Free body diagram tak payah. So linear kinematic, please put in the minus sign. Okay. And then we go for projectile motion. When we have an initial velocity V0, you have your angle here. Tak kenapa orang ni kat sini. So you resolve your UX and your UY. Remember that you have AX equals to 0 and your AY equals to minus 9.81. Minus 9.81. Okay, at the maximum height, your Vy equals to 0. What is your Vx? It is Ux. Vx and Ux is the same at all points. So, kat sini, this is your final velocity. You need to find out what is your Vx and what is your Vy. Baru dapat tahu vector kita apa, resultant, our final velocity apalah, final velocity vector. And then we need to know the angle juga. Sama juga, pakai all the equations related to vector untuk cari magnitude and also to find the angle. What else do we need to know? Okay, time. So the time for a symmetrical projectile motion, from here to here, it's T. From here to here is also T. So total duration is 2T. Sama macam free fall, it's still symmetrical. Range. This is your range daripada initial to final. Dia lain daripada maximum height. Maximum height occurs dekat midpoint of a symmetrical projectile motion. Range is at the end. So range ni bukan separuh-separuh Range ni sampai hujung. So tu perbezaan dia. So when you're trying to find range, you need to use 2T. When you're trying to find H, you will solve for T. Okay, apa lagi? I think that's it. Okay, what is the best angle to shoot if you want the maximum range? 45. Okay, Amy jawab 45. So betul So the best angle to shoot something to get the maximum range is 45 degrees. So this is the best angle. So how else can you increase the range selain 45 degrees ni? Apa lagi cara boleh increase range? Semua orang dah penat dah. Sepak kuat-kuat. Okay, so sepak kuat-kuat translates to apa? So Feli is saying increase velocity. Ya, betul. Sepak kuat-kuat is increasing velocity. Syaki jawab sepak kuat-kuat betul. So it just means you increasing your velocity. So increase your V0 or use the maximum angle. And another question that I can ask you, what factors affect maximum height? Please find out. Please find out apa faktor yang boleh bagi kita punya maximum height lagi tinggi. Okay, find that out. That's your task. So you already know what is the best way to get maximum range. What is the best way to get maximum height yang paling tinggi? Okay, find it out. Okay, next. Lagi saya ingin cerita Cover this one. Before kita go for web assign, apa lagi? Okay, this one, yes. So this one is confusing. Saya kena cerita balik. Okay, so now I'm asking you, okay, look at this diagram. Look at this diagram. Okay, dia tak gerak. Alhamdulillah. So look at this diagram. What is your SY? What is your SY? Can anyone tell me?
45. Negative 45.
Negative 45. Yang tu siapa jawab?
Amy.
Amy, okay. So Amy punya suara macam tu. Okay, saya cuba ingat. So Amy, macam tu suara dia. So minus 45. So everyone agrees with Amy. Ada jawapan lain tak? Semua orang agree? Syaki pun agree? No. So Feli is saying no. Why Feli? Macam no. Safa cakap macam no. Oh tak ni.
Go up.
Sebab dia ada go up sikit. Okay. Siapa agree dengan Feli? Itu Feli kan?
Yeah.
Oh, saya ingat nama suara Feli. Okay. So Safa agrees with Feli. Okay, jawapannya negative 45. Walaupun kita ada naik sikit. Kenapa? What is the equation for displacement? It's y final minus y initial, right? So kita start from here, we end here. So basically we want to know, kita nak tahu apakah y displacement saja. We don't care if dia naik ke apa ke. We just care about the final and initial. So this is something that selalu student make a mistake, even the smart ones. Sebab tu saya cerita balik benda ni. So kalau dia tanya SY, walaupun kita naik ke atas sini, our SY is tetap from final to initial ataupun initial to final. Okay, so that is your SY. So that is the beauty of linear kinematic. You can use the displacement. We are concerned about the displacement only. Okay, so that is your SY is minus 45. Kenapa macam tu? Apa dah gendut ni? So SY minus 45. Walaupun dia naik, saya faham kenapa orang confuse kat sini. Sebab saya pun awal-awal dulu confuse pasal ni. But if ada orang kan, dia buat macam ni tau. Dia cari, dia solve untuk this part dulu and then dia solve untuk this part. Boleh, jawapan dia akan sama tapi panjang lah. So kalau tak nak menyusahkan diri, kita nak hidup senang, kita pakai je displacement punya value which is minus 45. So okay doktor, saya confused yang horizontally projected. Saya tak tahu nak bezakan UX equal to 0 dengan mana yang tak. Oh, okay. Okay, so kalau kita nak tahu UX dia kosong ke tak, UX kosong, UI dia kosong ke tak, UX kosong ada ke? UX kosong kalau free fall. Okay, saya cerita lah. So if you want to know whether your velocity, initial velocity ni ada Y component ke ataupun ada X component ke ataupun ada both, so kita boleh macam cerita sikit lah. So if they say projected horizontally. Kenapa saya punya tulisan macam ni? Projected horizontally. So kat sini dia cakap projected tu maksudnya apa translation dia macam tu lah, projected tu menerus. I don't know what's it called. So projected horizontally. So maksudnya you only have X component. This is the word. So if they say thrown vertically. So you only have Y component, dia ke atas sahaja. If they say is thrown off a building with angle, ada angle, confirm ada X dengan Y. Anything ada angle, dia kasih angle je, confirm ada X dengan Y. Bila dia cakap projected horizontally, maksudnya that no Y component, X component ada. Ni apa noi? No, this is no Y. X lah X pula, tak sesuai. Tak ada lah, Y tak ada Y tak ada. Buat macam ni lah. Okay, Y tak ada. So when you are thrown vertically, ayat dia thrown vertically ataupun apa lagi ayat yang boleh cakap macam tu thrown vertically. Tak ingat lah, tapi thrown vertically lah yang selalu orang pakai. So X dia tak ada. Okay, so ada Y component saja. So kat sini UY ada, UX tak ada. Sini UX ada, UY tak ada. So these are the keywords. Maknanya thrown vertically boleh terus assume free fall. Yes, correct. When you throw it vertically, you will assume it as free fall. Betul. And again, kalau kita start dari sini and we end up here, walaupun kita ada komponen ke atas ni, kita rasa macam ada displacement ke atas ni. Tapi displacement punya equation is S final minus S initial, which is here and here. So we don't care about this part. Okay? Take note on that. What else? Okay, for this case, what time is it? For this case, yang ni kita throw ke bawah. So ini senang. Kita terus tahu SY dia adalah X final minus 45 minus initial 0. So it's just minus 45. Sini tak ada komponen ke atas ni. So kita boleh terus pakai. Tak ada confusion lah kat sini. Sepatutnya lah. Okay, hopefully that is the case. So siapa yang rasa confused about this one, yang tadi kita cerita tu, okay, buat soalan dalam web assign balik. Revise. Okay, let's do some web assign questions. Stop sharing this one. Kita dah habis cover chapter 2. Kita nak buat soalan pula. We have 15 minutes left. Chapter 2, share. So ada soalan tak yang saya miss out? Oh, Feli said, then I said one is for distance. Then I said one is for distance. Oh, okay, Feli dia nak retrace, apa tu? Nak revise jawapan dia. Okay, it is distance, betul. Okay. Mana chapter 2 kat sini. Yang ni korang tahu ke macam mana nak buat? This is chapter 1, dimensional analysis. Kita go over laju-laju. So this is F equals to G mass times mass over R squared, where F is the gravitational force, M and M are masses. And R is length. And force has the SI units of kilogram. Force has the SI unit of kilogram times meter per second squared. Okay. What are the SI units of the proportionality constant G? So it's asking here, what's G? Okay, let's do that. So F equals to G mass over R squared. Kita nak cari G. So we just bring this guy over here. So F divided by mass times with R squared, we get G. So now we put in our units. So F is given as kilogram meter per second squared times with meter squared over mass times mass, kilogram squared equals to G. Tak habis lagi cerita. Lepas tu kita cancel out dulu. So kilogram cancel out with this guy. We're left with 1 kilogram only. Meter, tak ada cross out. Meter times meter squared dapat meter cube. So this is meter cube. Second squared is divided. So kita letak kat sini lah. So this would be kilogram second squared. So this is the unit for G. Sama. Senang je kan? So just rearrange the equation and put in the units. Then cross out. Okay, chapter 2, jom. Okay, so a ball is thrown directly downward with an initial speed of 7.1 meter per second. So macam ni. From a height of 29.8. So dia start pada 29.8. Ni soalan yang ada orang request After what interval does it strike the ground? So dia start dengan U equals to minus 7.15. Remember, linear kinematic kena very careful with the signs. Minus 7.15 going down, so it's a negative. Apa lagi yang kita tahu? A is minus 9.81. Our height starts from 29.8. We want to go to the ground, which means that this is going to be 0. This is H equals to 0. Okay, okay. Dia tanya after what interval does it strike the ground? So saya tak tengok jawapan tu lagi. Let's just try it ourselves. So V equals to U plus 80 tak ada kaitan dengan S. Kita nak tahu ada kaitan dengan S. V equals to U plus 80. Ada orang jawab. S equals to UT plus 1 over 2 AT squared. Okay, let's do that. S equals to UT plus 1 over 2 AT squared. At this point, we don't know the time yet. We know the U, we know the S, we know the A. Okay, betul. So S, what is our S? Kita cari dulu siap-siap. S equals to S final minus S initial. Sorry, Y final minus Y initial. Y final is 0. Y initial is 29.8. So your answer should be minus 29.8. Do this one sebelum korang masuk dalam equation. Minus 29.8 equals to U is minus 7.15 T plus 1 over 2 minus 9.81 T squared. Okay, if you get this type of equation, what should you do? Kita dah belajar kan macam mana nak buat kan? Ingat lagi ke tak tu? Harapnya ingat lagi lah. Okay, so remember you use your calculator. What do? You go for equation. Tekan mode 3 kali. Tekan mode 3 kali, tekan equation. And then go for degree. Degree kat sini adalah 2. Tekan 2. What is your A? You rearrange this equation first. So kita start dengan T squared, T and then this guy. So this would be minus 9.81 over 2. Kalau nak jadikan positif pun boleh. So T squared minus 7.15 T. Bring this guy to the other side. Positive 29.8 equals to 0. So this would be your A, this would be your B value, and this would be your C value. If you wanted to make this positive, boleh. Positive, positive. This guy has to be negative. So you would get the answer for time. If you get your answer ada 2 jawapan, satu positif, satu negatif, pick the positive one. So let's do that one. Kita tahu jawapan dia, 9.81 divided by 2. And then B is 7.15. Hopefully I'm doing this correctly. Minus 29.8. Silap tekan. 4.89, 7.15, and then 29.8. So I get 1.84 and minus 3.2. So I get 1.84 for my time using the calculator. Adakah sama jawapan dia? Saya pun tak tahu. Dapat sama. Yeay. Saya tak suka tengok solution dia sebab solution dia confusing. So I like to solve it myself. So this is why I don't give you guys solution as well. Sebab kadang-kadang saya kena explain juga solution tu cakap pasal apa. So it beats the purpose of giving you guys a solution. Okay, so I hope everyone knows how to use the calculator untuk equation macam ni. Quadratic, yes. So it is called quadratic, betul. Quadratic equation. Next. Okay, so a student stands at the edge of a cliff and throws a stone horizontally over the edge with a speed of V0 equals to 23. So kat sini, okay, kita bincang pasal soalan dia. Throws a stone horizontally. Word dia horizontally with a speed of 23. So immediately you know that there is no y component. There's no y component in your initial. So ux is equal to 23 ataupun v0. Your uy is equal to 0. Does this mean that your vy will be 0? No. Sebab vy akan affected by gravity. So adalah value dia kemudian nanti kita kena kira. Okay, so the cliff is h 24 meter above a flat horizontal beach as shown in the figure. So this guy is 24 above here and then 0. So kita tahu height dia adalah ataupun sy dia adalah minus 24. So what are the coordinates of the initial position of the stone? So this would be 0 and this would be 24. I hope. Let's see. Apa jawapan dia? 24 and 0. The components of the initial velocity of the stone are, so Vx ada component and then y is equal to 0. Okay, kat sini. So next question. Number C, write the equations for x and y components of the velocity of the stone with time. Let the variable be t measured in seconds. So dia suruh bagi Vx in terms of time. So, tengoklah jawapan. C is V equals to U plus 80. So this is 23 plus 0t ataupun Vy. Oh yeah, betul lah tu. So minus 9.81. So basically dia pakai equation V equals to U plus 80. So because this is the equation that describes V in terms of t, right? So kalau Vx, kita tahu A dia kosong. This would be just 23. Then Vy, we know that this is 0 minus 9.81 t. So this is your final answer. This guy, minus 9.81 t. Dia tanya, the coordinates of the stone during its flight. So ini solve for Sx and Xy during its flight. Dalam bentuk t juga kan? Oh, so soalan ni dia cerita pasal equation lah. Okay. Write the equation for the position of stone with time. Do you need to know this? Yes, but dalam soalan MCQ kita banyak pakai values lah. I wouldn't say this is the normal question that you would see, but it's important for you to know lah. Okay, so I hope ini pakai equation je lah basically. So, okay, this one we use V equals to U plus 80. So we got Vx, Ux, then Vy, 0 minus 9.81 t. Untuk yang ni, S equals to Ut plus 1 over 2 80 squared. This is Sx, U is 23t. And then this guy is 0, so Sx is that. Then Sy is 0, Ut plus 1 over 2 t squared. U is 0 for Y. 1 over 2 minus 9.81 t squared. Macam tu je lah. So ada jawab, ada orang tanya soalan ke? Oh, tak suka tulis equation. Ni MCQ, so tak ada tak ada isu tu Boleh relate, betul. Saya pun tak suka. Kena tekan pilihan dia kasih kat tepi tu lah. Dah guna masih salah. Okay. So ni limitation of web design lah. Kadang-kadang ada isu dengan dia punya equation. Next. How long after being released does the stone strike the beach below the cliff? So it's asking the total duration je lah. So if kat sini dia buat, dia pakai SY. Dia solve macam biasa je lah. So kita dah tahu dia punya height apa kan. So kita just plug in je lah from here. From here. Kita dah tahu SY apa. Kita plug in SY. SY is 24 minus 24. 1 over 2 minus 9.81 t squared. We solve for t. So I would say this is quite straightforward lah sebenarnya. Cuma dia jadi pelik sebab dia minta equation. So I think that thing threw you off lah. So with what speed and angle of impact does the stone land? So find your Vx, find your Vy, find the magnitude and also the angle. Macam ni lah. Okay, kita nak laju sikit. So saya akan skip. Apa lagi soalan yang susah So this is number 22. So soalan projectile motion ni panjang lah. For a window, from the window of a building, a ball is tossed from a height. Why not? What time? Okay. So saya tak sempat cover juga soalan projectile motion with class K19. So I will make a video on these questions for them. So I will make these videos for you guys as well. So we don't have to continue our class ataupun continue our revision. I will give you a video after this and you guys can use that as to continue habiskan revision chapter 2. Is that okay with everyone? Supaya saya tak buat kerja 2 kali. Boleh ke?
Boleh, Doktor.
Okay, nanti saya kasih video for the rest of the questions. So ada soalan yang ni, kejap saya tunjuk soalan apa yang saya akan cerita. So soalan 22 saya akan cerita. Soalan 2 graph and then soalan graph ni pasal average velocity rasanya. Okay, average velocity. And then for instantaneous velocity. So tinggal tu je lah. So just 3 more questions. Okay, that's it guys. All the best nanti for Wednesday. We'll see each other on Wednesday too. No, on Tuesday. Okay, bye.
Okay, Doktor.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doktor.
Bye.
Thank you, Doktor. Bye, Doktor.
Bye. Ya, kasih Haikal. Kenapa? Hmm.